Well, thank you guys all for coming. It sounded like it was way more exciting out on the floor. This is Let's Get Scary and Continuously Deploy Database Changes. My name's Dan Mallott. I am the head of platform and infrastructure for Economic. Economic is accounting software for small and medium-sized businesses in Denmark. We have approximately 182,000 customers, and the teams that I manage are responsible for the foundation of the software. So we build the foundation, we take care of the infrastructure that our amazing product devs build features on. We are a company that is a member of the Visma group as well. If you're interested in a job, Visma is hiring. Now I've said the bit that they give me time to come to the conference for. So I still consider myself a software developer, even though I've been mainly developing PowerPoints recently. I've also been a DBA on occasion. I had a lot more hair then. And most of my experience is with Microsoft technology. Done a bit of work with some other database products, some other programming languages, notably the four-letter one. And I referee and play ice hockey. So when my wife and I decided to relocate from the United States, coming somewhere ice hockey is played was really important. So we chose Denmark because we wanted bad ice hockey. Yeah. So what are we going to talk about here? So I can't see you very well, but how many people out there are developers primarily in your day-to-day job? It looks like almost everybody. So the CI/CD thing is going to be just covering the bases, refresher. We'll talk about why data is a problem. In particular, when we think about continuous integration, continuous deployment, data can be a huge problem. We'll talk about how you modify the data model safely, and maybe not so safely. I'll do a bit of touching on automated testing. We'll close out with some demos about how you do this state-based versus migration-based. And I've chosen a couple of off-the-shelf tools for that. At my company, we've actually built our own tooling to do a migration-based deployment. And I'll talk about why that was chosen as well. Yeah. So you want to automate some stuff, right? We're developers, we're lazy. So automation's great. Continuous integration, we're all familiar with this, right? You merge your code in, or you push your code up, make a pull request, and an automated build happens. You get immediate feedback about whether or not your changes will compile. Not work, compile. And then continuous deployment is we take that artifact that we just created with the continuous integration build and we deploy it. So every change can be pushed automatically, assuming all your tests have passed, right? How many people have a test environment? How many people have a dedicated production environment? Well, that's pretty good. My teams manage 15 acceptance environments to allow our developers to test a lot of features in parallel. So it's cool. Right, so CI/CD, right? And we're really used to doing this with our application code, right? Whether you're writing it in C#, in Java, in Python, in Ruby, God help you. But databases are a lot harder, right? And there's a reason for that. Is that data is a problem, right? Data is not application code. Data records the state of your application, right? So when you change the state of your application, you have to be careful that you don't lose something important, right? If we think about it from a programming perspective, our data is stored as a resource, right? Yeah, anybody work with the old .NET regex files? Yeah. Back when I had hair. right? That's data, right? So whether we're storing in a regex file, in JSON, in a relational database, in table storage, in the cloud, whatever, right? Data is a resource, right? And it should be permanent. Although not too permanent, because we all have regulatory regimes, one in particular, that say we need to be able to delete data if somebody asks us to. It's a good thing all those systems that we built were designed after that regulation came into effect. And so when we think about changing the data model, right? So the data model is code, right? When we build a data model, we do it declaratively. This is what our data should look like, tables or objects or whatever you have, right? But if you change the data model, you might lose data. And losing data without meaning to is bad, right? And to compound this, our code and our data model are intertwined, right? No one has built the ORM that does things magically, although people are trying, right? So your code has to know what the data model looks like, right? And in some cases, your data model has to know what the code looks like. In particular, if you think about indexing, right? An index is an opinion about the code. Yeah, so losing data is bad, which means that we need to have a strategy when we go to change the data model so that we don't lose data or know that we're losing data. And we all have backups, right? Right? Oh, I've got some laughter up there. That's not good. And everybody's tested them. Yeah. You know, this is a place where the cloud has really changed things, as an aside. Like, you know, if you're running Azure SQL Database, which is what I have for the demos, it's great. I've got a backup there. I didn't have to do anything. Now, I only keep 7 days of backups because I'm cheap, but it's there. And if I had an enterprise budget, I could keep a little bit more. Yeah, so how many people out there have a data store that is the authoritative source for that data? It means this is the store for the data in the organization, and it's the one that is authoritative. Any place else it's copied is just a copy. Like, this is the original. Yeah, I got a couple. Yeah. How many of you don't know? I got a couple. Okay. Thank you for your honesty. Yeah, so this is interesting, right? Most of my work has been on transactional databases, and transactional databases that are the source of truth for the data. So that when it gets copied into a reporting environment or into a CSV format, those things are just snapshots of a point in time based on what's in the transactional database. Not everybody has that, right? Sometimes we're dealing with an external data source. Sometimes we're, grabbing a copy from somewhere else in our organization and just working with it. That's okay. So, but if you do, right, if this is the authoritative data, then you might want to think about taking some more care when we change the data model, which I'll start talking about here in a second, how we do that. Mainly because one of the databases that one of my teams manages is our user store, right? And this is, the users, what SKU they've bought, what their permissions are, their email address, things of that nature, right? And we feed this data other places. So our BI folks use this data to generate usage statistics, and our salespeople use this data from BI to do upselling, right? Like, hey, you're using this feature a bunch, maybe you should use this one, or buy this one, right? So when we make changes to our data model, we need to tell people. And that means you have to talk to people across your organization. Talking to people is scary. And there might also need to be more gates, right? So everyone has an automated test suite that perfectly covers all of the use cases of their application. Fair, right? Yeah, no, none of us do. There are gaps, right? But it means that when you're making a change that changes your data structure or potentially changes the data, you really need to make sure that you're either covered with the automated tests you do have, because we all got some, or you have a test plan. Because, fun story, so, and I'll come back to this a couple of times. One of the projects that we're doing right now is we have some tables that are actually running out of integers on their identity columns. So the Danish government, in their infinite wisdom, passed a law last year that says every business that has a CVR, right, a VAT number, has to use an electronic accounting software. And part of the electronic accounting software that we have, that we offer, is we manage a lot of files, right? Invoices, receipts, other files, right? Well, it turns out that 2 billion was plenty when the system was designed in 1997, but it's not in 2023. So we're actually running out of integers. And it has taken us a while to make this change because it's changing from int to big int, right? Not a big deal. But it's taking us a while to make this change because testing this is really complex, and our documentation is not the best. Not a negative, just it's 25-year-old software. Right. So how do we change the data model safely? And how do we maybe not change it safely too? Okay. So generally, if you're adding things to your database, to your data model, this is fine, right? Now, there are some cases where, like, if you're adding a table or an index or something like that, like, make sure there's enough space. So the example I was just talking about, we're actually, instead of just upsizing the column on the table, because that would take, well, we tried it and it took 18 hours and then we killed it. So we're actually copying the data into another table. Well, that's space. And our DBA was like, so we're running out of space on the drive? Oh, yeah. Right, so check with the DBA team if there's storage. Add the table to whatever MDM you have, right? That's sort of a good, good rule of thumb anyway. Right, same with a view, add to MDM, check your indexing. If you're adding a view, check indexing, because make sure there's an index that supports the query the view is executing. Other things, yeah, it's generally fine, right? If you're adding a trigger, tell the DBAs and buy them beer or drink of their choice. Maybe don't buy it in Norway. Come down to Denmark and buy your beer and come back. And then, if you're adding a column, right, no one ever does select star in production code. So that's definitely safe, right? But this is fine for the most part. But you do have a backup, right? Because we're going to talk about removing things next. Yeah. So if we drop things after a backup, what do we have to do? Yeah. Generally, again, this is pretty much fine as long as we've made sure to preserve the data. Now, I'm very clearly American, right? So we have a few more regulatory regimes than just the GDPR. But they're all pretty consistent on this one. Like, don't lose data. unless you absolutely mean to, right? So if you're dropping a table, right, update MDM, make sure you've got a copy of the data somewhere. Somewhere. If you're updating, if you're dropping a view, right, again, we want to update MDM, maybe we want to drop some indexes too. Stored procedures, constraints, fine. One thing on constraints is business logic is important, and we generally enforce it via constraints because it isn't being enforced at the application level, or because we don't trust the developers who are working on that to enforce it at the application level. And I don't want to get into a conversation about check at every level because that's just off topic. But yeah, if you're dropping a constraint, make sure it's not needed. Like, are you sure? Are you sure we want this column to be nullable? And maybe explain to the product owner why that might be a bad thing. Again, if you're dropping a trigger, now you're going to get that beer money back in the form of beer. And column, just make sure you've got the data. Again, these are not really, really awkward operations. What are the awkward operations when we talk about altering the data model? Yeah. So I'm not going to work in the joke about naming things and off by one errors and all that, but naming things is hard and renaming things is even harder, right? It's the same as like if you go into your code, okay, like maybe we have Rider or IntelliJ if you're in that world or whatever, and we have got really great refactoring tools, right? But how many people have gone into code and gone, I need to rename this thing, but it's like in some strings in some places, and so I'm just going to do like a find all and replace, and then all of a sudden the code doesn't compile. I'm like, oh crap, what did I do? Yeah, so let's talk about renaming a column, right? Now, when you rename a column, you're going to break every query that depends on that column name. It will no longer run. It will give you an error, and it will, if you're working with SQL Server, be reasonably comprehensible for SQL Server, right? But this is pretty easy, right? We can, if we're doing this sort of generically, we can add a column, set some names, or set some data, right? Copy the data into it, drop the column. If we're in SQL Server world, we have a nice, convenient stored procedure for this. But like I said, this is a huge breaking change. So you might want to add an alias to the table, an alias to that column on the table, a computed column, right? And you might want to run it this way for a while, just until you make sure that you've gotten all the consuming code. This is a place where observability can really help, right? So we've been making a bunch of changes where we change the way things are called, and we set a monitor in Datadog to say, hey, this is still being called this way. And you can do it the same way with your computed column name, right? Set a monitor like, hey, this thing's still being, some query somewhere is still using this old column name, so you can track it down. Renaming a table. Syntax is really easy, but again, you're going to break everything. Everything that depends on that table, including the downstream things that consume it, right? BI, other, maybe, that Excel app that nobody knows is running. Maybe the Excel app everybody does know is running and you're breaking it on purpose. That's okay. But the thing is, just like with the column, it's going to change. It's going to break things internally to the database as well, right? If you have a stored procedure, who actually likes writing stored procedures? Yeah, okay. That's expected. Who has to write stored procedures because their DBA team told them they had to? Oh, that's good. This is good. We're getting places in the world. Yeah, it doesn't have to be all stored procs. Anyway. Right, but if you change the name of the table, you're going to break something. And unlike with the column where like the engine might tell you, if there's a stored proc that uses the table that you just renamed, it's not going to tell you until you execute it. And it goes. It's a version of this talk where I had the Tony Stark with the explosion in the background, but I thought it was a little too much. Right, so we can either engage in some scream ops, in this case. We can use our observability tools, right, which is a different form of scream ops, as all of the monitors turn red. Or you can, you can define a view, right? So just like our computed column, the view is just going to say, hey, give me all the columns out of my renamed table, and I'm creating it with the name of my old table. And then we can kind of give ourselves some backwards compatibility and some grace as we move backwards in time. Because otherwise we will inevitably break something for somebody. Okay, but really, kind of my point here is we need to protect against broken business logic. Now, there are a lot of different ways to do this on the code side of things. I've seen good ones. I've seen bad ones. I've seen ones that work, but you kind of go like, well, that's a 40-minute build time with all those tests. Is that really worth it? But right, on the code side, we can protect ourselves against it with a combination of unit and integration testing, whatever that looks like in your environment. But on the database side, right, how do we do that? We don't really think about testing on the database side. Who has business logic in their database? Does anybody have a foreign key in their database? You have business logic. You might not think about it as such, but it is business logic, right? Yeah, so, and I should have put this slide up before I asked for the hands so I could actually see you guys. Yeah, unit testing is your friend, right? Unit testing is your friend on the application side, right? We've all known that for like 15 years now, right? How long ago was it that The Art of Unit Testing came out? That Manning book with the samurai on the front? Like, it's been a while, right? This is part of our development process. It's ingrained to us now. But we also should be thinking about applying that to business logic in the database. Now, again, how many of you have a unit test suite that does a variant of testing the framework? Yeah, come on. Everybody knows that developer that's like, oh, I'm going to get 100% unit test coverage, and like they're writing unit tests on properties. It's like, come on, no. Right? So when we think about unit testing our database, business logic in our database, like, do we need to unit test foreign keys? Probably not. Like, if our database provider messed up the implementation of a foreign key, we should be shopping for a new database provider, not like testing that it works. But like if we have a stored procedure or a function or maybe some sort of like weirdly complicated view, like those things are candidates to be tested, right? And they probably should be. Now there are a couple of ways that you can test in the database. You can write your own harness, which is what a lot of people do because this is a kind of awkward thing to do. In the SQL Server world, you've got T-SQL-T. And then there are a bunch of others in other parts of the world, and apparently my slide with them all has gone missing because it should have been next. But essentially, like, the example here is, so I've got a stored procedure here on the left. And this is in the pretend world of running against the Stack Overflow database. So we've got, does this work? It does. So we're just incrementing someone's reputation, right? Let's say they've either gotten an upvote or gotten a downvote. And we have some decision points in here, right? So like, if the user didn't get passed in, we want to throw an error. If the reputation adjustment amount didn't get passed in, we want to throw an error. If we gave an invalid user ID, right? So this is some sort of basic sanity checking logic. We should be testing this, right? Because not only are we testing that our logic works, but also we're guarding against changes. So all of a sudden, if our user's table's name gets changed, our unit test suite will tell us because it'll fail, right? So we want to do something like that. And in the T-SQL-T world, which is what I've come to prefer, although it's not what we use where I work, it's really easy to write these sort of unit tests, because it's just like, hey, it looks really similar to what you'd write in C#. Like, I'm expecting this exception with this message and this error number, and then I run the stored proc. And this can be integrated into your CI/CD pipeline as well. Time check. Now, when we think about deployments of our application code, most of the time we're doing something where it's either a blue-green deployment or we have a previous version of the code that we can roll back to. This is not so easy in database world, right? So in the database world, we should always be trying to roll forward. There's a reason for that. So but before I get there, right? So when we talk about managing database source code, right? And that's what I mean by that is the data definition language. So what our tables look like, our views, our stored procedures, those types of things. There are two versions: state-based tools, which represent a bunch of SQL files that represent this is what the database should look like. When I deploy it, generates a script that looks at whatever is there in the database, whatever is in the model, generates a script to fix the differences. Two most notable examples: SQL Server database tools and Redgate SQL source control. And then on the other side, there are migration-based tools. Who here uses Entity Framework with code first? Yeah. Oh, God, I love that. Love seeing that too. But yeah, code first is a version of migration-based source control for your data model, right? So you manage the creation of migration scripts that move the database from one version to the next. And sometimes you can roll back as well. Depends on the tool. And usually you maintain a baseline version. So for example, I mentioned earlier that we wrote our own migration-based tool. And the reason we did that is because nothing existed when it was written that did what we needed it to do. Which is essentially allow us to deploy database changes in any order, so that we weren't tied to a specific order of pull requests being deployed. We deploy between 6 and 8 times a day, so having that sort of flexibility is really important. Some commercial versions: Flyway, Liquibase, Ruby on Rails migrations, probably the most famous and well-known one. Other ORM migration tools, right? Entity Framework, code first, that type of thing. Right? So this is how you're going to store your database shape. Now you'll notice something about the state-based tools is that they always generate a script to do the change. And the migration-based tool, you're always moving the database from one version to the next. Although if you pay Redgate for Flyway Enterprise, you can actually roll back. I've had talks with some people from Redgate, and they say, yeah, you really shouldn't do that. We support it, but don't do it. Right? But so why are we always rolling forward? And really the answer becomes, if we always are making changes based on what's there and not trying to go backwards, the state of our database and ensuring that state becomes much easier, right? There's not a, like, have we deployed this change or not situation. The other thing that we'll avoid is if you are making a change that's destructive to data and you have to roll it back. So say or take a different example. Say you've changed the column width. Like, so I had an email column that was 100 characters. That's just clearly wrong, so we're going to increase it to 253. Well, so I can go forwards with that. Going backwards, that most database engines aren't gonna let you do that, right? But if you roll forward, then you can write the code in such a way that, like, okay, well, we need to undo this, so I can write a state change that undoes it. Unfortunately, this isn't a magic bullet. You might have to do a restore sometime, right? The goal of rolling forward is to avoid having to do a database restore. Our main database is 7 terabytes. Now, thanks to the magic of Google and the cloud, that restores in like 10 minutes. But that's still 10 minutes that our application's offline. Yeah. But the other piece is, with rolling forward, is we want to make sure that our changes are backwards compatible. And this is something that we do fairly easily with API design, right? Like versioning APIs and making sure that we're not going to break something. But we want to do it with our database changes as well. Now, I get to look at our cloud bill. Storage is not cheap. Storage is not cheap. But it's cheaper than having the software be offline. So, and this, of course, brings up a different issue. So, this is particularly important when we're thinking about state-based changes, but it's good to keep in mind for migration as well. Item potency is really important, right? So we want to be able to run the same operation multiple times and not get into an error state. So that means when you're doing database deployments, you check to see if the change has already been made before you actually executing the change. I have some examples of that. And yes, it gets complicated, but this is why we get paid well. Who wants to see some demos? Yeah. All right. So, is that big enough? Maybe one more? All right. So, as I mentioned, I chose a couple of off-the-shelf, one migration-based, one state-based. And we'll take a look at the state-based one first because it's maybe more interesting. So, SQL Server Data Tools was for a long time Microsoft's like, this is how you should do database source control. And nobody used it for various reasons. But essentially, what we have is, and I've organized this by schema, so I've got my DBO tables, and I've got my data load, which is stored procedures, and a user-defined type. It's a fun story for another time about why that came into being. And this is, as you might maybe guess, a database to store data on Lego. So Rebrickable produces a data set with all of the Lego sets parts, minifigures, etc. from the last however long it's been around. Right, and so these SQL files, and we can take a look at one, describe the shape of the database. It's really straightforward, right? It's just a create table statement. I've got my primary key there, a clustered index. I've had other indexes. I could put it in here. I could put them in different files. And when this thing gets compiled together, it creates what Microsoft refers to as a DAC pack, D-A-C-P-A-C. That then it's just a bunch of XML because it's an enterprise problem, so let's solve it with XML. And then that thing can be deployed against wherever. You generally configure a target. In my case, the target's SQL Server. And it's got what should look fairly familiar to anybody who's done a lot of C#, except instead of a CS proj, it's a SQL proj. And unfortunately, I can't demo this building locally because, the SQL Server data tools don't work on a Mac. They don't work on an ARM-based processor either, so I can't even boot up Parallels. So hopefully they'll fix that at some point. And then essentially you can just build this by doing something like this. And it's just a Visual Studio build. And this works in whatever build system you use. I'm using Azure DevOps here. You could use TeamCity. You could use Jenkins. You could use whatever. GitHub Actions, I think. Although, note for SQL Server data tools, because it only runs on Windows, you're going to be paying for Windows agents in GitHub. So, yeah, that's an additional bill, right? And yeah, so let's add a table, right? And I've done some demo scripts already, so I don't have to do a bunch of typing here. But we're just going to add a parts SSDT demo table to this database. I guess I should prove that it doesn't already exist there, and maybe wake my database up. Right, so got my continuous database deploy server here, and it did go to sleep. SQL Azure, the serverless SQL Azure is great for saving money, but just be careful how you configure it's going to sleep. So yeah, you can see like my table list here, I don't have that table yet. So let's get it there. Oh, and there is data in this database as well. Just to prove there's data in this database. Maybe. There we go. Yeah, there's data in the database. Right. So no ignoring the man behind the curtain here. So let's add this table. And so to do this in the state-based way, literally all I have to do is drag it in here. Yep, I do want to move you. Thank you. Now we want to fill it with data as well. The way you do that in the state-based world in SQL Server data tools is through what are called pre- and post-deployment scripts. So those post-deployment scripts, in this case, we're gonna, and this is what I'm talking about item potency, right? So in this case, if this table is here, fill it with data from the parts table. And it's a small enough table that it's not going to take forever when we run it. So we'll come in here, set this guy to run. And the last thing I have to do is make sure that that table gets included in the build. We'll go ahead and get push that up. The internet's cooperating. All right, we can come over here. come back out to our pipelines. Go ahead and run this. And what this will do is it will go ahead and pull our changes, build that DAC pack as I was mentioning. Failed to communicate with the agent cloud. Demo is a 4-letter word. Yeah, so eventually we'll get an agent, otherwise this will be, okay, there we go. Otherwise this will be real unfortunate. So it's going to pull our changes, it's going to build that DAC pack, and then in our case, I've chosen to just go ahead and deploy that DAC pack straight to the server. Now I'll note this is a demo, you probably don't want to do that. Like, you probably want to have a separate deploy step, particularly with something like this. And you also note that I'm running no tests of any sort, because again, it's a demo. But what you can see is we're building, and you get some similar output to what you get from normal C#. Writes the model. You'll notice it's XML, because of course it is. This is also not incredibly fast. But when I ran it earlier, it was not this slow. Wonder if I'm running into, I guess the working day has started in the US. Wonder if I'm still running on US agents. There we go. Right, so build finished, and then we'll deploy. And yep, you can't see my password, so that's good. Not that you can access this database anyway, because firewalls are good. You can see it says, okay, here's the DAC pack file. And do some initializing of deployments. So why running these things automated is good, because then you don't have to, like, you know, you can go up and get a coffee and come back and you get the answer. I want to win something too. I never win anything at conferences. Like, never. Right, okay, so now we're updating the database. It says we're creating the table, it says we're creating the foreign key, and it finished so fast that it flipped away before I could talk about it. Yeah, and so that's it, right? So this says it ran successfully. Let's go prove it. So we'll refresh the table list. Hey, here it is. Parts, SSDT _ demo. Okay. Now let's prove that the data ended up in there. Azure Data Studio has it in for me today. I also did not choose a very powerful database. Okay, yeah, so you can see the parts are all in there, right? Great. What if we wanted to do the same thing with a migration-based tool? Plot twist, it's going to be much easier. So let's take a look at Flyway. So Flyway's convention and many other migration-based conventions is you have a version identifier. In my case, I'm just going 1, 2, 3, 4, 5. And then you name that version whatever you want it to, and it processes them in order. And literally, all it does is process them in order. We can take a look at the configuration file. You can see, yep, configuration file is pretty useless because it's just for local. But if we want to do a parts Flyway demo, right? So now this is the same thing I just did in the state base, but with migrations, and this looks a lot simpler, doesn't it? This is a lot nicer looking, at least from a developer standpoint. Like, I had to do a lot of stuff in the other one. All I have to do on this one is, well, let's move it. Push it up. It's up there. They're having a lot of fun down there. I wouldn't blame you guys if you left. And so we'll take a look at this pipeline because this is a lot simpler. There are a lot of different ways to run Flyway. I'm just installing the tools on the build machine and running a migration. But essentially all this does is run Flyway migrate with a bunch of parameters, including the user, the name, JDBC URL, and that's it. That's pretty much what it does. So we'll take a look at this. And you'll notice this is also a lot faster, even with having to install the tools on the build machine. Failed to communicate with the agent cloud again. My lucky day. Yeah, okay, so checkout is normal. They use Flyway as I'm just going to install that particular version, which is quite nice. I have, on occasion, updated my local Flyway and broken everything, which is why I do this in the cloud now. All right, so we run the migration, and you'll be able to see the, yes. So it says Flyway, right? Gives me my database. Successfully validated 14 migrations. My schema was on 13, right? That table wasn't there. That migration hadn't been performed. It says, okay, migrate it. Applied one migration. So we're now at version 14. And that was quick, right? So let's go prove it. Close this guy. Hey, our Flyway demo table is there now too. And I bet it has data in it. Note to self, next time just have the queries ready to go. Yeah, so we got data, right? And it happens to be the same data, which is fine. Okay. But like I said in the slides, adding things is really easy. Let's go rename things. And we'll start with renaming in SSDT, right? So now for this, all I have to do in our state-based, can you guys still hear me even though over the stuff there? Yeah, okay, good. Then I'm just going to keep talking. So in my state-based, right, because the state-based database project says this is how my database should look. So all I have to do is swap my SSDT demo with underscores with the one that doesn't have underscores, right? Because we don't use underscores in SQL Server, it's weird. So I'll move that in there, move this back out there. Okay, swap around what we're actually including in the build. And we'll have 2 deployment scripts. Why do we need 2? That's weird. We're just renaming the table. Well, let's take a look at what we're doing in those. So because we can't be sure how this state change is going to be executed, right? Now, logically it says if I execute a rename in SQL Server, I'm just going to use rename, right? Or if I'm in Postgres, alter table, rename, right? But we can't guarantee that's how our state-based tool is going to actually do it. So, right, we're going to need to preserve that data somehow, because what if it issues drop table, create table? Anybody played around with Atlantis for Terraform management? Yeah, if you change the name of something, it drops it and recreates it. Not what you want necessarily, right? So If we have our old table name, we're going to create a temp table and copy our data into it on the front side, so that then, we don't have to deal with it. And then on the back side, this one, we're going to insert into the newly renamed table and drop the temp table. This is kind of a pain, but this is what we're working with when we're working with state, right? We have to think about how we're moving the database from one state to the other. So we'll go ahead, save these things, and as an aside, we're going to get some much more interesting output. When we go run the build. You finished, you finished. Run a pipeline. Right. And 3 for 3. When I do the migration-based demo of this, we'll see if I get 4 from 4. Right, and so the reason that nobody has really used SSDT, or not no one, but the reason the adoption level is fairly low is because that sort of like, let me awkwardly work around how state is managed can be really prone to error. And if you don't know what's happening, now there are some guardrails. Like if I had just run that with the data in the table, it would have said, I can't make this change because there's data in the table and the change might be destructive, which is nice, but it's also not what you want in your continuous process. Building the database. Come on, get to the interesting part. There we go. As an aside, if you've enjoyed NDC Oslo, definitely think about coming down to Copenhagen for the Copenhagen Developer Festival. It's held in a really interesting part of the city. There's a really awesome barbecue and beer place nearby, and it should be a really good time. I've apparently used up all of my Azure DevOps karma for today. Well, while we're waiting for this, I'll go ahead and come back over here and make the change for the migration one. And so that's all I have to do for the migration one. None of that, like, let's swap some tables around and let's run a couple of files. It's just, let's rename the table. And so if we go ahead and push this in here, we'll go ahead and third time's the charm. Oh, hey. Why are you stuck? Well, it was worth a try. Have you tried turning it off and back on again? Am I still on over here? Yep, I'm still on over here, maybe. Did we? Well, you would have seen a really cool looking demo, but, here we go. I have confidence in you. Wow. Okay. Sometimes you win the build agent lottery and sometimes you don't. So that's what we'll call that one. Yeah, okay, cool. Now we're publishing. And what you see is we'll start the deployment and it will run our pre-deployment. Yep, all right, well, I give up.
It's Friday afternoon. You should never deploy a database on Friday afternoon.
But it's before 4 o'clock. Yeah. So it's funny because, okay, there we go. It's funny you say that. The gentleman says it's Friday, you should never deploy a database on Friday. It's interesting because I mentioned we deploy 6 to 8 times a day, and that does include Friday. Yeah, we shouldn't be afraid of deploying on Friday. But if we are, we should look at why that is. So anyway, that's a side note. Right, so you see we did some stuff, and if we come back over here, we will now see that it has been renamed, but our old table has not been dropped, which is interesting. So something went wrong, which I will have to look at a different time. In any case, we're nearly at time for this talk. I have time for a couple of questions. Yep.
This migration tool, can that be run as a separate process at the customer, or is it only this script?
Yeah, so the question was, can the migration tool be run on a remote location, like say on a customer location, or does it need to be run locally or on the build machine? And the answer, at least for Flyway, is you can run it wherever you want. It's a command line tool. You can install it. You can run it in a Docker container. It has no reliance on running on a build machine. So that can be a very useful thing, and particularly if you have remote databases that you need to update. Anybody else? Yeah.
Do Flyway or other tools, do they check for tampering or for manual changes in the database?
Yeah. Do Flyway or other tools check for manual changes? So you might have noticed that my state-based deploy did not destroy my Flyway tables. And the reason for that is because I set it not to. Flyway doesn't. Flyway only executes, Flyway and other migration-based tools generally only execute what you've written as scripts, and it ignores any other changes that have been made in the database. And if there's a conflict, then the script just fails, right? State-based tools generally say, this is the state I expect in the database, this is the state you've given me, so I'm going to wipe away everything that I don't know about. Now, as you can see, you can set it to ignore other changes, but then it ignores all the other changes. So that there's a trade-off there. I mentioned we wrote our own migration-based tool. One of the reasons we did it was so that we could get a bit of state checking as part of our deployment. All right, it is 4 o'clock, so thank you guys all for coming. I appreciate it. I hope you had a great conference, and enjoy the ending keynote.